Here have actually heard of Cynefin. I need to check that within the software development. Okay, so not a huge amount, that's useful. Okay. My goal today is to introduce the Cynefin framework to you. It's extensively used within Agile and elsewhere. And then talk about some of the new programs we're doing at the Centre for Applied Complexity on radical new approaches to user requirements capture and project management. Right? Now, in half an hour, the best I can do is give you a sense of what they're about. Yeah? And this stuff tends to be what's called theory-informed practice. We're not trying to derive theory from what people do. We're going back to the natural sciences and say, what does science teach us is possible? And then derive practice from that. Now, that's a whole new way of thinking, but it's really important for conditions of uncertainty. But it means this is a bit of a conceptual switch in some ways from what people are familiar with, which means that this is my signature cartoon, I think, right? Some people would want me to cross out the constructive side, and I'm okay with that if you really need it. Right? So, Cynefin is a Welsh word. For those of you who don't speak Welsh, which I assume is the majority, it literally translates into English as habitat or place, but nobody would translate it that literally if you were Welsh. In fact, the English don't have an equivalent for it. What it means is the place of your multiple belongings. It's a sense of being rooted in many different pasts, which profoundly influence what you are, but of which you can only ever be partially aware. The reason the English don't have an equivalent is they've never had a place of their own. They've only ever stolen other people's, and we haven't forgiven them for the 13th century yet, and we don't plan to anytime soon. Right? But it's a very good name for a complexity model, because complexity is always about living in a present which is only partially determined by the past, in which you cannot know the future. So there's a sense of being part of a flow of time. And if you think about it, anybody trying to design software these days, you're dealing with multiple past experiences of software related or different, of environments of hardware, which people are partially aware of and not fully aware of, and you deal with a highly uncertain future. In fact, if I come back to it from a theoretical perspective, a future where you cannot know the future is not a matter of forecasting accuracy. It actually says it's inherently impossible to know the future. The best you can do is describe the present. Right? So that's what the Cynefin framework is about. So I'm going to run through it briefly, emphasize something, and then talk about some practices. So the first thing, this comes back to the science. There are three types of system which exist in nature. It doesn't matter whether you go to physics or biology or chemistry, there's kind of like conformity on these. Not all the same language is used, so I'll define my terms. Chaotic systems, complex systems, and ordered systems. Now, different definitions. I'm going to use what's called the constraint-based definition because that leads to action. If I have a system which is highly constrained to the point where everything is predictable, it's called ordered. Yeah, there's a level of predictability, there's repeatable, there's cause and effect relationships, the same thing will happen again the same way twice. Human beings are very good at this. So, for example, in hospitals, we count the number of surgical instruments left at the end of an operation and check it's the same as were there at the start. Okay? As I get older, I think this is of increasing importance. I know the numbers that were left inside bodies before that checklist procedure was instituted. It's actually quite a scary percentage. So that ability to create highly predictable, highly controlled environments is extremely useful. Yeah? The trouble is we then get carried away with it and we take it to excess. What's interesting, and this is very important for software testing, is rigid control processes with checklists only work in highly ritualized environments like an operating theatre. In fact, we've done work by which changing the clothes that people wear before they go from development to testing changes the way that they think. Yet ritual entry into a process actually changes cognitive activation patterns of the brain, and you have to put a lot of work in to getting people to act in a highly structured way. It's not natural for us. Yeah? Therefore, an operating theatre, an aircraft crew, a firefighting crew, all of these are ritualized environments that can apply processes that do not work outside of them. Which is why you see a lot of things that work in nuclear testing software, for example, do not work in application software because the environment and the expectation are completely different. Yeah? So order has value, but then the trouble is, as I say, we take it to excess. So for 7 years of my life, I worked for IBM. That was a valuable learning experience. It taught me about bureaucracy in a way that no other organization possibly can. They took over the company we worked for, and the first thing they did was to ban alcohol and get rid of free coffee. Now, this is a highly disruptive element for anybody who's in software development. I mean, a dichotomy between alcohol and coffee consumption was essential to productivity. Yeah? Alcohol was associated with creativity and design, coffee with getting you ready to execute, and then alcohol to deal with the users. All right? There were various combinations. But we decided we'd go along with it. And, well, we had no choice, really. And then they came in and banned all food. They said, you can't buy food for staff anymore. Now, by this time, we'd learned that you don't argue against bureaucrats with logic. That's a mistake. The only way to deal with bureaucrats is to ask them innocent questions on the basis you really think their idea is great, but there's this one minor problem. Could they help you deal with it? It probably won't work, but if anything works, that's the only thing which will. So I said, what happens at 2 o'clock in the morning, where the only way to keep a team awake to deliver a client-critical product at 9 a.m. the next day is to buy them pizza and Coke. And I do mean the drink, just to be clear on this. I don't want any misunderstanding. And they said, oh, what do you think? Now, never answer this one. We said, well, we don't know. This is a well-thought-out policy, so I assume you've allowed for it. But, Americans don't understand irony either, so that's quite entertaining. You can use it as a deadly weapon. Yeah? And they said, oh, tell you what, if you ask permission 48 hours in advance, then it may be permittable. Now, don't lose your temper, right? Okay, so we'll do that. That's very sensible. We like that idea. But what happens on the very rare occasion where we don't get 48 hours notice of a crisis? Being ironic again, right? What do we do then? And they said, country general manager approval after the event. Now in IBM, that means your expenses will disappear. They'll never get signed off. If you complain about it, your name will appear on the wrong lists. Bureaucrats are experts at saying yes in a way which means no. So the practice emerged of over-tipping London taxi drivers. Because if you over-tip a London taxi driver, you get a blank receipt. You then fill out the blank receipt for the amount of food you bought for staff at 2 a.m. in the morning, get them to sign a form to prove that you spent it on them, not on personal use, submit the expenses, and it got paid, and everybody was happy. Yeah? Now, I spoke about this at Scrum Alliance in Berlin last year. 3 people from IBM rushed up to me afterwards and said, we're still doing that, did you invent it? And somebody from IBM HR took me on one side and said, we knew you did that sort of thing, why are you making such a fuss about it? And you realize the way in which order produces the wrong results. Just to be clear, I've seen the same approach in excessive ordered approaches to software design. I've seen it in excessive approaches to use of Kanban. I've seen it in the total disaster, which is safe. All of these things try and create order where order is inherently impossible, as a result of which people have to work around it, and you get massive inefficiency. So order has value, but within boundaries. Chaos, I'm using chaos in the sense of randomness or lack of connectivity. Basically, there are no connections, there are no constraints between anything, so everything is completely random. Now, that means it's a temporary state. If it's accidental, it's a disaster. Used deliberately, it's an innovation space. And we're now doing work, for example, a project in Singapore, where we use hundreds of thousands of people in real time to answer a question of policy without knowledge of what other people are doing in very high abstract structures. I'll explain some of that later. Effectively, by introducing controlled randomness, we got objectivity of decision-making under conditions of extreme uncertainty. That sort of builds on wisdom of the crowds, if you know literature on that. An American submarine which went down off the coast of Portugal, they gave partial data to different groups of experts around the world. None of them knew who the other experts were. They were all disconnected. Yeah, they all gave an estimate of the position. None of them got it right. But a probability distribution of the estimates was within 300 meters of the submarine. Yeah? So actually we're now starting to use that, and there's good cognitive science and statistical reasons why that works. So if you can actually create a system where there's no connectivity between multiple agents, you can produce a highly objective way of making decisions under conditions of uncertainty. Right? So these things have value, provided you understand their basis. And then there are complex adaptive systems. Now, we've only known about these scientifically for about 40 or 50 years. It comes from Prigogine and others. A realization there are systems which are not linear and causal. The same thing will not happen again the same way twice except by accident. Actually, it's core to evolutionary biology, all sorts of things. In a complex adaptive system, the constraints are partial and are modified as people interact with them. So the agents and the constraints are constantly co-evolving and constantly changing each other, which means they are inherently uncertain. The level of change is such that you cannot predict the future. And to make a very clear statement in English, but a very difficult statement to get conceptually, complex adaptive systems are not causal, they're dispositional. You can measure the dispositions of the state and the way in which it's likely to evolve and less likely to evolve, but you can't make any accurate statements about the future. Now, in a world of disconnected systems, of social computing, of the Internet of Things, we are dealing with a complex world with high levels of uncertainty. Managing that on the assumption of order is a fundamental error. Now, the best way I've ever learned to illustrate this is to think about different ways of managing a children's party. Because basically, the type of the system will lead to different types of management. If it's an ordered system, you manage it one way. If it's a chaotic system, you manage it another, and so on. So imagine, if you can, a party for a bunch of 6 or 7-year-olds. Everybody can imagine this? Some of you're young enough to remember your own. Some are probably going through it for the third generation. Right? And you're holding it in your own house because you haven't learnt the value of community centres is that they have fire hoses. Fire hoses are useful for cleaning up after parties and occasionally are needed for crowd control during the party itself. So let's look at how you would organise the party. If you assume it's chaotic, it means the children are completely unconnected and unconstrained. So they'll probably discover drugs and alcohol and go on a personal experience of self-discovery. Your house may burn down in the process, but all property is theft and it was socially constructed in the first place, so why are you worried about this? I don't recommend this. I've got a friend in California who did try it once, but he's never going to do it again. The recovery cost is very high. The ordered systems approach, on the other hand, you'll understand. Under this, you agree learning objectives for the party in advance of the party itself. The learning objectives have to be aligned with the mission statement for education in your local society. They're clearly articulated and printed off on motivational posters with pictures of eagles soaring over valleys and water dropping into ponds, and placed around the walls of the room where you're going to hold the party. You then produce a project plan for the party. The project plan should have clear milestones throughout the party against which you can measure progress against ideal party outcome. And the senior adult should start the party with a motivational videotape. You don't want the children wasting time in play which isn't aligned to the learning objectives. And they should also use PowerPoint to demonstrate their personal commitment to the party and show the children how their allowances are linked to the achievement of the milestone targets. Following the highly successful completion of the party, you conduct an after-action review, update your best practice database on party management, and mandate future process improvements. If for any reason at this point the children aren't happy, you hire an appreciative inquiry practitioner who will teach them how to tell happy clappy stories so they have happy mental models and suitably indoctrinated are like whatever you put in front of them next time. Everybody reasonably familiar with this approach to party management? The complex systems approach, on the other hand, is much simpler. We start off by drawing a line in the sand, known as a boundary in complexity theory, and we look the children squarely in the eye, and we say, "Cross that, you little bastards, and you die." One of the things you learn pretty fast as an adult is the value of flexible negotiable boundaries, because rigid boundaries have a habit of becoming brittle and breaking catastrophically. We then introduce catalytic probes, a football, a video, a barbecue, a computer game, in a hope a pattern of play will form. That's called an attractor. If it's favourably disposed, we amplify it. If it's not favourably disposed, we dampen it. So we manage the emergence of beneficial coherence within attractors, within boundaries. Yeah? And that's the radical new aspect of complexity thinking. You manage what you can manage. You manage the boundary conditions, you manage the probes, you manage rapid amplification and dampening. Yeah? By the way, there's a whole new approach on this on project management. I'm working with Prince 2 at the moment, so possibly the next release of Prince 2 will have a whole new approach based on complexity, in which you don't allow aspects of a product to define except by interaction with users over time. And this point, I'll come back to this later, you start to destroy the role of the systems analyst because they provide an excessive constraint and eliminate weak signals. Now again, I'll explain that in a second or two. Yeah? So complexity theory doesn't say that order or chaos are wrong, it says all three are different and we need to manage that. So from that, we basically get the Cynefin framework. It's drawn like this. It's not a 2x2 matrix. It has 5 domains. I saw somebody there say it's the 5-quadrant model, all right? You can't have 5 quadrants, guys, all right? That's basic English, but never mind, all right? 5 domains. It divides order into 2, obvious and complicated. In obvious order, the level of the constraint is so high that everything is completely predictable, so we have the domain of best practice. Yeah? Our decision model is we sense data, we categorize it based on what we already know, and we make decisions accordingly. Yeah? So, for example, we all know, don't we, that in civilized countries, people drive on the left-hand side of the road. So if you're in a civilized country and you drive on the right-hand side of the road, you can expect negative consequences. I'm old enough to remember when Sweden went from being civilized to uncivilized one weekend, and I still remember watching it on the television. It was fascinating. Right? The point is, some of these things are conventions we accept. Right? They don't have to be things which are rigidly true, but everybody accepts them, therefore you can rely on them. Yeah? In complicated order, on the other hand, the constraints are governing. They're looser in terms of the way they work, but within those constraints you've got predictability. So the model here is sense, analyze, respond. There are degrees of freedom, there is some degree of variation, but I've got constraints I can actually monitor. So I sense, analyze, respond, and I use good practice, not best practice. Very important distinction. In good practice, people with expertise can vary the practice. In best practice, no variation is allowed. Yeah. Then we get on to the complex domain. In the complex domain, we have what are called enabling constraints. I haven't got time to go into this, but a heuristic, a rule of thumb, is an enabling constraint. A rule is a governing constraint. Yeah? An enabling constraint allows huge degrees of freedom within a coherent whole. If you want a metaphor, think about an external skeleton on an insect and an internal skeleton on a human. Yeah, the external skeleton constrains everything within a narrow confine. The internal skeleton allows massive variation around some sort of coherent structure. Now, this actually is where most software development needs to take place. Yeah, it's kind of like some constraint but not too much. And effectively what we do here is we probe, sense, respond. We can only understand a complex adaptive system by interacting with it. It can't be studied. It can only be studied by action. Yeah, and actually this is what we call a shift from fail-safe design to parallel safe-to-fail experimentation. For those of you into Agile, Scrum is a complex to complicated transition tool. And actually one of the things we're developing are pre-Scrum tools in Agile which deal with this parallel experimentation. Yeah, which Scrum doesn't actually handle. It's very valuable, but it's not on that side. Yeah. Then a chaotic space is one where we have to act, either to maintain it or get rid of it. It's completely novel practice. Now, lots of people in software development use Cynefin, but they stop there, and that's a pity. Because they're forgetting about the 5th domain, that bit in the middle, which is the domain of not knowing which of the other ones you're in, which is a bad place to be. Because it means you'll do whatever you feel comfortable with. And they also tend to forget the reason the bottom is drawn as a cliff, that's that squiggle, is if you make something highly constrained where it shouldn't be, sooner or later it collapses over the edge into chaos. Excessive constraint builds tension into the system, which actually breaks catastrophically. So that's kind of like key, but really Cynefin is about dynamics. That's where people really get it wrong. So the fundamental dynamic for any organization or for any country or for any software program, this stuff is fractal, it's self-similar at different levels. The normal dynamic is things emerge in the complex space through experimentation, through probes, through structure, As they start to work in a consistent way, you can apply constraints and get repeatability. If in applying constraints you get repeatability, you've moved it from complex to complicated. That's what Scrum does, through linear iteration. Once it's there, you can exploit it, because the same thing will now happen again the same way twice. If it stops doing that, you need to move it back into complex. And that's one of the troubles. A lot of software programs will work initially, but after a year or 2 years, they stop producing repeatability, and people try and force people into them rather than realize it's trying to shift back into the more dynamic phase. So this complex to complicated cycle is a natural cadence. In retail, it's really fast. In aircraft manufacturing, it's quite slow. And there are different cadences between legacy management system and novel-based apps, even in consumer care. So understanding that cadence is key, and the key test is actually constraint. If you don't do the switch back, you may have to do this. It's called a shallow dive into chaos. You've allowed the system to constrain where it shouldn't, therefore you're at danger of fracture, so you kind of like deliberately move it into chaos before it falls into it. You create disruptive innovation, to use a Clayton Christensen concept. Yeah? But you do it deliberately with malice aforethought. Yeah, you do it quite deliberately before it would happen naturally. Then you can sort of control the exit. Yeah? Very, very few things go down there. Yeah? To actually put things there means you've admitted you're not going to have to change them for a significant period of time. Yeah, so some apps, for example, I used to do work object wrapper in legacy management systems for banks. Yeah, if you're going to put the investment in to put an object wrapper around the body of Fortran and COBOL, you want to do it once, you don't want to have to go back and change it every year. Yeah, so there are some things that you put the investment in to get them there, they have high utility, but if they're going to need to change, you mustn't ever put them in that space. Increasingly these days, we're seeing a fourth dynamic, which is called the grazing dynamic. The level of volatility of user requirements is such that you never ever stabilize the system for long enough to really get repeatability. And this actually, for some of us, is actually very exciting new use of object orientation, because it allows us to actually allow systems to assemble and reassemble. So applications become emergent properties of objects interacting with people over time, rather than being things which are designed. Yeah, and there's a growing body of work here we're working on systems architecture, project design, project management, which says for aspects of what we're doing, we'll never stabilize long enough. So we need build systems designed for inherent instability. Yeah, and there's a body of work going on that. It also means there are some key inflection points. As we start to move into that boundary, we have to make a decision. This is something that we're going to stabilize for a long term, stabilize for a short term, or it's only very temporary. Yeah? As we move down here, is can we afford to move this into the obvious domain, and kind of like a very quick double check, are we really sure? There's a double check point on that. And then if we go through some type of disruption, is it disruption because we failed to change things, or because the conditions require continuous change? Yeah. Now this is a sense-making framework. You'll notice what we're doing here is not to say there is an answer, but there are different ways of looking at the problem so the right answers are more likely to emerge. Yeah. So software design, user requirements, is more likely to be in the complex domain. Building into manageable code is probably more likely to be in complicated, and most things will probably stay there these days. Yeah, they won't go beyond that. Yeah, so most of the software techniques I've seen are complex to complicated or complex complicated techniques. You have got this rather insane thing going on in IT at the moment. People say, my method is complex, yours is complicated. The implication being that you're an inadequate human being who can't cope with complexity like I can. And then we got some even more insane people who are saying, well, I'm in the chaos domain, I'm a wizard, right? Now, the minute people say that, you should take them out and shoot them for the sake of humanity and for their own sake, right? The reality is all domains have equal value. The key thing is to understand which you're in, but as importantly, how you're trying to move between it. Yeah? Now, it also links in with cognitive neuroscience. So just give you a very scary quote. This is basically a repeatable test. Radiologists asked to detect a cancer nodule, yeah, and if you look at the figures on that, it was 48 times larger. They put a picture of a gorilla in it, which is huge. Asked them to look for anomalies. Yeah, 83% didn't see the gorilla. 83%. Despite the fact that Anne's eyes physically scanned it. That's radiologist. What the hell do you think happens with the systems analyst? Yeah, if you conduct more than 2 interviews, your brain forms a subconscious hypothesis and you only pay attention to things that match that hypothesis thereafter. And if you say your training prevents it, then you probably had formed a hypothesis before the first question, but you're too arrogant to realize otherwise. Yeah? We do not see things that we do not expect to see. This is part of being human. Yeah? And if you think about it, it makes a lot of sense. Just to really scare you, the most of what you scan of what's in front of you is 5%. That's on a good day. Right? And then you match it against patterns stored in your brain, your body, and your tools. It's all 3. So a radiologist, let's come back to radiologist again, has 30 to 40,000 patterns associated with their skill and training. They scan an X-ray, 5%, and they do a first fit pattern match, not a best fit pattern match. So the most frequently used patterns are more likely to be activated first, and this starts to explain why people tend to follow old familiar pathways. In evolutionary terms, you can see why it happened. Yeah? The early hominoids on the savannah of Africa. Something large and yellow with very sharp teeth runs towards you at high speed. Do you want to autistically scan all available data, look up a catalogue of the flora and fauna of the African veldt, and having identified lion, look up best practice case studies on how to deal with lions? By that time, the only document of any use to you will be the escape manual from the digestive tract of a large carnivore. And the only example I've found of that is the book of Noah in the Old Testament, and I don't suggest you build a software development strategy on that basis. Yeah? We evolved to make decisions very quickly based on partial data scans. And what's interestingly, if you change the way that people dress, you can change the patterns which get activated first. That's what ritual does. You see the point about theory-informed practice? We don't try and find something which worked, we try and understand why things happen and then develop practice from that. So that leads me into kind of like what I hinted at. This is a narrative landscape. This is some methods we developed, and I haven't got time to go into them, but basically they use what's called high abstraction metadata. So has anybody filled out an employee satisfaction survey? Yeah, does your manager consult you on a regular basis, scale of 0, not at all, 10 all the time? Everybody familiar? You know exactly what answer they want, so you either give it or you take it away. Yeah? We take a different approach. We say, what story would you tell your best friend if they were offered a job in your work group? That's called a non-hypothesis question. Yeah? Then we get people to interpret it on a series of triangles, a method we developed and patented. One of the triangles basically says the manager's behavior was altruistic, assertive, analytical. Now notice those are 3 positive qualities. And that actually confuses the brain. It puts the brain into what's called novelty receptive, not autonomic mode, which means it thinks deeper. And that gives us very high-level metadata. This came from counterterrorism and weak signal detection. That's the origins of this work. You can't afford for people to know what you're looking for, because then it changes how they perceive the world. You have to move to this higher level of abstraction. Critically as well, this is human metadata, not machine metadata. Yeah, I've lived through the big data hype 3 times in my career, and I now characterize it as one algorithm to rule them all and in the darkness bind them, right? Yeah, it's the belief you can write an algorithm which can replace a human being, which could only happen in a community which is deeply autistic. And for people who are deeply autistic, it might be true, right? But for the rest of us, forget it, right? So this is actually capturing a huge amount of data. This is engineering data. What we're then doing is mapping the dispositional states. And that actually has something like 200,000 or 300,000 observations in it. Yeah, and I won't go into the detail, but you can see how a system is disposed to evolve and how it's not. But critically, you also focus on outlier events. Now, we use this for cultural mapping to indicate, because cultural change is not about deciding where you want to be, but nudging forward from where you are to somewhere different. You can see an example of a nudge on the right. The top right is unsustainable, but there's a bit in the middle which I could go to. So I can basically click on that, read the narratives, and say, what can I do tomorrow to create more like this and fewer like that? You move away from these models of change based on idealistic statements. But what we're also now doing, this is an experimental program we'll shortly announce within the new Centre for Complexity at Bangor University in Cardiff, a process by which you nominate a number of users who continuously keep observations on a day-to-day and an hour-by-hour basis of what works and doesn't work. As you get patterns emerging from those multiple observations, once you hit a statistical critical mass, IT can develop prototypes against those narratives without further authorization. Start to see where this goes? You're immediately moving into a faster dynamic interaction between IT capability and user frustrations without asking them what they need. So you're linking unarticulated needs with as yet unknown capability, and that then feeds into things like Scrum. We're also doing the same thing for user requirements testing, for software testing. Once you start to move software engineers' testing journals into this type of format, you can start to build machine learning based on training data sets, which will alert you when the multiple observations over multiple players indicate a predisposition to software errors within code. So there's some very, very exciting stuff coming forward on this, but it's moving back behind the traditional requirements point, behind the traditional checklist, into recognizing we're dealing with inherent uncertainty and developing methods based on that. I hope that was useful. Thank you very much for your time. If anybody wants further details, the website has it, or take a card. Oh, no questions. Oh, I thought I was forbidden if I went on time. Any question? Anyone have an argument? Yep.
So you told about this, that we have 3 different systems ordered, complex and chaotic.
Yeah.
But do they scale so that if something is for me very ordered, it could be very chaotic to somebody else?
Yeah, I think, and it's an important, I was going to say it's a good question, but I made that mistake in Sydney a few years ago, and somebody said, I didn't ask you to rate my question, I asked you to answer it, all right? So I gift that one to you, it's a really good put down. Think about the way things are, the way we know things, and the way we perceive them as 3 separate things. In fact, there's a version of Cynefin which does that. So there's reality, there's how we know it, and how we perceive it, right? Now, most of the time, those are not aligned. Yeah? So actually, if you increase the frequency of the interaction of perception with knowledge with reality, they're more likely to be aligned. Right? So given your background, I may see things as complex, somebody else may see them as complicated. Right? It doesn't mean that they're not absolutely one thing or another, or that aspects of them aren't different, but the perception is a part of what you're trying to deal with. Right? There's a general heuristic, by the way, if in doubt, assume it's complex. And the basic test for a complex system is if the evidence supports contradictory interpretations, it's complex. Yeah? And for each of the interpretations, you construct a safe-to-fail experiment. You don't try and resolve it because it's inherently unresolvable. For any coherent explanation or idea, you get a small amount of resource and then you see what happens. Yeah? Any more? Yeah. Cool. Okay, yeah. Anybody say any more information, feel free to get in touch, and I hope it was useful. Thank you.